Alright guys, welcome back to another video, and today we'll be going through Unit 6, Lesson 3, which is solving systems of equations using the substitution method. So as you guys can see, we have 4 systems of equations, and I'm going to teach you guys of how to use the substitution method to solve these equations. And you guys might think that, okay, just because I've learned one, why do I need to learn all the other methods, right? Couldn't I just use one to solve all of them? Well, in theory, you could, right? But some equations, some systems of equations, are actually easier to solve using certain types of methods. And you guys will understand as I complete this video. So let's hop right into it. So our first system of equation, negative 6x plus 5y is equal to negative 22. Y is equal to negative 8. So what do we do first, right? We notice that we only have one variable in the second equation, but we have two variables in the first equation. How will we do that then? Well, we know that y is equal to negative 8, right? So couldn't we just substitute the negative 8 into the first equation to solve for x, just like how we've done in the elimination method when we solve for one variable, right? Let's do that. So now that we have y equals 1, 8, we have y equals negative 8, negative 6x. Let me move this up here so you guys can see. So we have negative 6 times negative 8, or oops, negative 6x plus 5 times negative 8 is equal to negative 22. From here, negative 6x minus 40 is equal to negative 22. From here, add 40 to both sides, negative 6x is equal to 18. So you're going to have x is equal to negative 3, right? And so this basically shows that the full coordinate is negative 3, comma, negative 8, and obviously you don't have to solve for the second coordinate because it's already given to you in the question. And not all substitution questions will look like this. Obviously, as you guys can see, as you look around to the other questions, some of them actually have two variables in both. This is probably the easier version of the substitution method. But let's go to the next one now. So for this one, we have y equals 4x minus 19, and then we have y equals negative 2x plus minus 1. Well, obviously, we still have to use the substitution method, right? But now we see that we have a variable instead of a number for y equals in the second equation. So, couldn't we just substitute the y in the first equation for negative 2x minus 1? So basically what I'm saying is that, okay, here, it's up here. So basically what I'm saying is that, so for y, right, we know it's negative 2x minus 1. So instead we could say negative 2x minus 1 is equal to 4x minus 19, right? So what you're doing is you're basically inputting your y value, what your y equals in your second equation for your y in your first equation, right? And so from here, we obviously know how to solve for this because we've done these types of equations in Unit 1, right? So you add 2x on both sides, you'll have negative 1 equals 6x minus 19. And if you guys don't know how to do this, you guys make sure to watch those first videos that I've made. I think it's Unit 1. I don't know exactly which lesson it is, but you guys can go check that out. Alright, so now we can add 19 to both sides, right? So you'll have 6x is equal to 18. And so x is equal to 3, right? X is equal to 3. And now we have to solve for y though, because we don't have both, right? So from here we can use the second equation because it's easier. Y equals negative 2 times 3 for the x value, so negative 6. Negative 6 minus 1 is negative 7. And so this gives us, just kind of be mindful of our space, this gives us 3, comma, negative 7. And I know you guys can't see this, so let me move this to the side over here. Alright, so that's our answer, 3, comma, negative 7. Alright, so now let's go to the next one. Y equals 4x minus 3, and 2x minus y equals 1. So we can do what we just did in the first the question right before this, right? We know that y equals 4x minus 3, so let's input that in our second equation. So we can write 2x. So we can write 2x minus, and then we have the 4x minus 3. Always, guys, make sure to put whatever expression you're inputting for your y value in parentheses. Always make sure to do that. Otherwise, you're guaranteed to get points marked off. Always do that. And you'll see why in a minute. 2x, and then see, look right here, right? You need to distribute that negative sign into both the 4x and the negative 3. If you didn't put a parentheses, right, you only distribute that negative into the 4x and end up making you get the question wrong. So make sure to put the parentheses around that. So 2x minus 4x plus 3 is equal to 1. From here, negative 2x plus 3 is equal to 1. Negative 2x is equal to negative 2. X equals 1. From here, let's do that. Let's put what x equals 1 into the first equation. Y equals 4 times 1, which is 4 minus 3. And this gives you 1. So our point will be, let's see, 1, comma 1. So yeah, that's correct. So yeah, guys, that's basically the second to last question. Let's go through one more real quick. And you guys might, as you guys look into this one, you guys might think that, how are we supposed to do substitution for this one? We don't have anything that's in the y equals format, right? Well, guess what? We've learned in past videos how to manipulate our equation to make it into slope-intercept form. So let's see the first one, right? The first one's probably going to be easier to put in slope-intercept form because it has no coefficients for the x or y. So we have x minus y equals 5, right? So couldn't we just write negative y? Okay, oops. So couldn't we just write... Let's move this over here. Couldn't we just write that negative y is equal to negative x plus 5? And then from here, just divide by negative on every single side, so you'll have x minus 5, right? So, oops, x minus 5. So this is what we have now. Y equals x minus 5 is the same exact equation as what we would have as in the first x minus y equals 5, right? So now that we've gotten to this form, let's input what y equals to into our second equation. We have y equals x minus 5, so let's put that into our second equation. So let's see, we have 2x plus 6, and then parentheses x minus 5 is equal to 10. Alright, so from here, 2x plus 6x minus 30 is equal to 10. 8x minus 30 is equal to 10. And then we have 8x is equal to 40. And then so x is equal to 5, right? Now that we have x, we know what to do. Let's input x into our first equation. Actually, let's use our equation y equals x minus 5. Let's not use the x minus y equals 5. If you want, guys, you can, but I think it'll be easier if you use our y equals mx plus b format equation. So we have y equals 5 minus 5, which is equal to 0. So our final coordinate will be 5, comma 0. And that's basically it, guys. That's what your final coordinate will be for this final equation. And if you guys want me to put more questions in, or if you guys have any questions, make sure to put it down in the comment section. And then yeah, so this will be, and so after this we have one more lesson, which will be finding systems of equations for inequalities. Now I'm not gonna do like every single thing. I'm not gonna do graphing equalities, substituting equalities, elimination of inequalities. I'll probably just do one of those. But yeah, so that's basically it, guys. Thank you for listening in on lesson 3. I think this one is. And I'll see you guys in the next video. Thank you for watching.